So this is the 2016 Leave Insert Higher Level Paper 1, and we're looking at question number 6. Part A, differentiate the function 2x plus 4 all squared from first principles with respect to x. Okay, so for differentiating from first principles, we're trying to show that the limit as h goes to 0 of f of x plus h minus f of x all over h. We're trying to find that. The limit as h goes to 0 of that. Okay, so we have our function here. Now before we start, I'm going to expand this function, 2x plus 4 squared. So 2x plus 4 squared is 2x plus 4 by itself, and that's equal to 4x squared plus 8x plus another 8x, and then 4 by 4 is 16. So that's 4x squared plus 16x plus 16. So that's my function. Okay, so what I'm trying to find then is the limit as h goes to 0 of f of x plus h. Well, if I replace these x's here with x plus h, that's going to give me 4 bracket x plus h squared plus 16 by x plus h plus 16 minus f of x, which is just this function here, 4x squared plus 16x plus 16, and that's all going to be over h. So that's going to give me the limit as h goes to 0 of I'm just going to do this off to the side here as well, x plus h squared. Just going to deal with this x plus h squared separately. That's equal to x plus h by itself, which is x squared, x by x, plus hx plus hx, and then plus h by h plus h squared, which is x squared plus hx and hx is 2hx plus h squared. So that's what's going to be in here. So it's going to be 4 times that, 4 times x squared plus 2hx plus h squared, plus, I'm going to multiply some of this out now. 16 by x is 16x, 16 by h is 16h, plus 16, and then I'm going to multiply this minus by each term, so it's going to be minus 4x squared minus 16x minus 16. And again, this is all over h. So now I'm going to multiply this out here. So I've got the limit as h goes to 0 of 4x squared plus 4 by 2hx is 8hx plus 4 by h squared is 4h squared plus 16x plus 16h minus 16 minus 4x squared minus 16x minus 16, and again all over h. So lots of tidying up to do. So we've got the limit as h goes to 0. Okay, so now I'm going to just identify my h squared terms. X squared minus 4x squared, so they cancel. And I've got 16x minus 16x, they cancel. Then I have, so that was a positive 16 here, positive 16, positive 16. So my final cancel there is the 16 and the 16. So they'll, positive 16 minus 16, that all the things I've highlighted will give me 0 when you add them all together. So what does that leave us with then? That leaves us with 8hx plus 4h squared plus 16h. And that's all over h. So it's the limit as h goes to 0 of this. Well, now I'm allowed to cancel h everywhere I see it. So divide above and below by h. So h into h goes once, here it goes in once, and here to leave me with h. So I have the limit as h goes to 0 of 8x plus 4h plus 16. And the limit as h goes to 0, as h tends towards 0, well 4h will also tend towards 0. So that's going to give me 8x plus 16. And that's it, differentiated from first principles. Okay, part B. 1. If y is equal to x sine of 1 over x, find d by dx. So we have to differentiate this. Okay, so we can see here that this is going to be, it's one function multiplied by another function of x. So it's going to be the product rule. Okay, so you've got a function u and another function v. So we're going to use that product rule. First of all. So dy dx is equal to u, which is x. This is my u and that's my v. So it's equal to u by dv dx. So it's x by the derivative of sine of 1 over x. Now, just as an aside, the sine of 1 over x is equal to the sine of x to the minus 1. So here I can use the chain rule. This rule here, both these taken from my tables book. So I'm going to use the chain rule here because this is a function within a function. So the derivative then of this would be, the derivative of sine x is cos x. So the derivative of sine of x to the minus 1 is cos of 1 over x, or cos of x to the minus 1, by the sine, by the derivative of this function, by the derivative of x to the minus 1. And when I bring this, when I differentiate this, I bring the minus 1 to the front. So it's going to give me minus 1 by x to the negative 2 when I reduce the power. plus v, which is the sine of 1 over x, multiplied by du dx, and the derivative of x is just 1. Okay, so what that gives me then is I have x by the cos of 1 over x by minus, we can write this as minus 1 over x squared. If I bring the x to the minus 2, put it as 1 over x squared, plus the sine of 1 over x. So that's my dy dx. Part 2. Find the slope of the tangent to the curve y equals x sine of 1 over x when x is equal to 4 over pi. And give your answer correct to 2 decimal places. So I'm just going to rewrite this here again. So x dy dx is equal to x of cos of 1 over x by minus 1 over x squared Sorry, just to go back here, I think this can, so this can actually simplify a bit more. So if we multiply this x here by the minus 1 over x squared, the x, this one, and one of these x's here will cancel, leaving me with that. So actually it's going to be the cos of 1 over x by minus 1 over x plus the sine of 1 over x. So that's going to be minus 1 over x by the cos of 1 over x plus the sine of 1 over x. That's it simplified right down. Okay, so that's what I'm going to use then over here. So dy dx is minus 1 over x by the cos of x, by the cos of 1 over x plus the sine of 1 over x. So that's my dy dx. And now I'm going to find, it says find the slope of the tangent to the curve. Well, that is what dy dx is. I have to find it when x is 4 over pi. So I'm just going to substitute 4 over pi in here for x. So it's going to be minus 1 over 4 over pi by the cosine of 1 over 4 over pi plus the sine of 1 over 4 over pi. Okay, so that's going to give me 1 over 4 over pi. Well, that's the reciprocal of 4 over pi, so that's just minus pi over 4 by the cosine of, again, the same thing. The reciprocal of 4 over pi is pi over 4 plus the sine of pi over 4. Okay, so when I put all of this into my calculator, you can just do this all in one go. And make sure your calculator is set to radians when you're doing this. It will give us a value of 0.1517, and on it goes like that. We want our answer correct to 2 decimal places. So we're going to look to the third digit after the decimal. Does this 1 affect the digit, the 5 in front? And the answer is no. So our answer correct to 2 decimal places is 0.15. And that's the end of the question.